12-2. 12-2? 6-2. Wrong class, sorry. Picking up in 6-2, where we left off yesterday, talking more about vectors, okay? Specifically, we're learning how to use the dot product, okay? Now, picking up on the back side, our next piece of information is that vectors are considered, and I have a vocab word here for you, orthogonal.
Ooh, I like that word.
Orthogonal, which, okay, it's a word, it's, you know, that goes along with vectors, but basically it's about the same as perpendicular. So basically, if we're saying that two vectors are orthogonal, we're saying that they are perpendicular, meaning? What a perpendicular? Intersect how?
Through the middle. Right? Or even. At the origin. No.
Two lines are perpendicular. They meet at what type of angle?
A 90-degree.
90-degree angle. Okay, so, sorry, I thought perpendicular was a given at this point in our lives. I take it we've since forgotten that?
I just took my Alex test for math. I don't know anything. Turns out. Actually, I'm doing better than Trenton and McKaylee put together.
But Kylie.
Or Kylie.
You know stuff. I know you know stuff. I know all three of you know stuff. But. Okay, so vectors are considered orthogonal. Almost the same meaning as perpendicular, which when we say perpendicular, we're talking 90-degree angle. And how do we know if vectors are orthogonal? If their dot product equals 0. So another application of dot product is what we're looking at here. So, example 4. How are we going to prove that vectors u and vector v are orthogonal?
Multiply.
Multiply them and see if they're
Equal to 0.
Equal to 0 when you do their dot product. Okay, so we are going to multiply u times v, which means we're doing their dot product, right? So we're doing vector 2, 3 times vector -6, 4. Okay, flashback to yesterday. How do we do the dot product?
2 times -6 plus 3 times 4.
Okay, 2 times -6 plus 3 times 4, which gives us?
-12 plus 12, which gives us 0.
Okay, -12 plus 12, -12 plus 12 is 0. So what did we just show? The vectors are orthogonal. So anytime you see that vocabulary word orthogonal, where we're talking about perpendicular, check their dot product. Okay, in other words, does the dot product equal 0? Okay, now, quick visual. I don't know if you guys care about the visual as much as I do, but I think it's always nice. Vector 2, 3. Where is vector 2, 3?
Up to right there.
I'm going to reverse that.
Oh, goodness.
I'm going to go right 2, up 3.
Sorry.
Oh, I did just.
So there's the first vector. -6, 4.
Right. Or let's 6. Up 4.
Left 6, up 4. Okay, we don't know 100%, but does the picture make the vectors look like they are orthogonal?
Yeah.
Yeah, that looks like a right angle to me. Okay. Question there? Okay. Well, continuing along. Let's continue along to our last piece here, which has to do with orthogonal vectors, but talking about something called a vector projection. Okay? So a vector is projected onto another vector by dropping a perpendicular vector from one vector to the other. To find the projection of u onto v, we have a formula we can use.
This looks like Walmart. It's a little loggy.
It's not loggy though, it's just how they express the formula.
I trust you.
Okay? So that is the projection of v onto u, or excuse me, u onto v. Okay, so with that formula, specifically it is u onto v, and as it's dropping one vector onto another. How does that read? If a vector is projected onto another vector, it's dropping a perpendicular vector from one to the other. So, for example, let me give you a picture here, or attempt to. If this is vector v, okay, and then the vector u is up there. The idea of a projection, or dropping that vector onto v, is that, I'm not good about showing the right angle there, but you drop it a perpendicular vector, so right angle, and then the vector is now on v. Okay, and you would often call this u1, because it is a projection of vector u, and so we name it u1. Okay, and again, and then this would represent a right angle there. Okay, so that's the idea of what a vector projection is doing. Now, example 5 has us using this formula. It asks us to find the vector projection of u onto v. So that's using the formula. And then, the secondary part, it asks us to write u as a sum of two orthogonal vectors, one of which is the projection. Okay? So, with that in mind, let's start by finding the vector projection. Okay? So we're going to find the projection of u onto v. And since we're trying to find that vector projection of u onto v, I'm going to name it u1. So it has a name. We're going to use that given formula that is the projection of u onto v, which is u dot v on top over absolute value of v squared on bottom times v. Okay, I haven't filled anything in. I'm just trying to get the formula written out.
The first thing we do is find the magnitude.
Well, it's one of the things we'll do. I was going to go ahead and fill in numbers here. So like on top, if I'm doing u dot v, what am I going to fill in on top?
6, 2 times 5.
Okay. What if can we go ahead and do the math, or do we not want to do that?
Oh yeah, we can do that.
I know, I haven't been, but I was going to on this one. So if we do the math, it's the 6, 2 times the 5, negative 5. So we're going to do what?
6 times 5
6 times 5.
plus 2 times negative.
2 times negative 5. Okay. I'll come back and complete that math here in a moment, but that's what's going to go on top. Yes? On bottom, it's the magnitude squared. How do I do the magnitude? And that is a v, sorry. How do I do magnitude?
V is equal to 5 squared plus negative 5 squared.
Okay, so to do magnitude, or absolute value, remember it's the square root of v1 squared plus v2 squared. So square root of 5 squared plus negative 5 squared. But what do we also have to remember? It's squared. So you're squaring the square root. Now, and I'm just going to, for the moment, say it's also times v here, isn't it?
Yeah.
I don't want to put the extra numbers in quite yet. It's times v as in it's times vector v. I'll put that in here in a moment when there's not so much other stuff going on. Okay. Can we clean up this fraction? On top. Six times 5 plus 2 times negative 5 is 20. On bottom, the square root of 5 squared plus negative 5 squared, quantity squared. Okay, 5 squared is 25. Negative 5 squared is 25. 25 plus 25 is 50. And then it's the square root of 50 squared. What's the square root of 50 squared? 50. So this is just going to be 20 over 50. And then times still vector v. What do you know about 20 over 50? It's 2/5. So if I say 2/5, and then I could go ahead and put in, but I'm out of room, times vector v. So all of that work there was simplifying basically our coefficient. Okay. What is vector v?
5, -5.
So we're going to do 2/5 times the vector v, which is 5, -5. Basically take that 2/5, that constant or scalar, and multiply it to each piece. What is 2/5 times 5?
10/5. Wait.
You're upside down. Well, you were right on the first part, but then you became upside down.
2.
Yeah. I could go with 10/5, but really just the 5's cancel, it's 2. Second part? 2/5 times -5 is -2. So right there, we just found our vector projection, which is u1. Okay? Well, that's it with the first part. And actually, I'm just going to write this over here that u1 is 2, -2. Just so I have that and I can see it. Now, the second part of this asked us to write u as a sum of two orthogonal vectors, one of which is the projection. Now, what is our projection called? Our projection is called u1, yes? Or at least that's what I named it. That's just the common way to name it. We're being asked to write u as a sum of two orthogonal vectors, one of which is the projection. So one of which is u1, and the other of which we don't know yet, but I'm going to call it u2. Okay? Now look at this. Do we know u? What is u?
6,
6, 2. Equals. Do we know u1?
Yes.
u1 is 2, -2. Plus, do we know u2?
No.
Not yet.
You just subtract over it.
Exactly. Basic equation solving skills here, folks. If u2 plus that one vector equals the other vector, then how do we find u2? We're going to subtract. So basically, you're going to be doing u minus u1. So in order to do u2, I'm going to be doing the vector u, which is 6, 2, and subtracting the vector u1, which is 2, -2. So u2 becomes what? We are subtracting.
4,
4, 4. 6 minus 2 is 4. 2 minus -2 is also 4. Okay. Now, almost there, we just have to write our final answer. It said, write u as a sum of two orthogonal vectors. So, when we set this up earlier, we said, okay, u is going to be u1 plus u2. Do we know u1?
Yes.
Do we know u2 now?
Yes.
Yes. So we can write u as a sum of two orthogonal vectors. u1, which is 2, -2, plus u2, which is 4, 4. And that right there is the statement that we would be looking for. And you can check your math. Do these two vectors add to be u? 2 plus 4 is 6. -2 plus 4 is 2. And that matches up to be u. Okay? So that is your projection formula. You will want to have that in front of you when you're working these problems. Okay, you have work time. Page 464, 1 through 18, 23 through 26.